rational equations. This usually means there's x on the bottom, by the way. That's what it usually means when you have rational equations, is you have variables on the bottoms of fractions at some point. So I'm going to show you two techniques that are completely different on two different problems to introduce to you 4.6 solving rational equations. We're pretty much just solving for x. So this is how I would do something like this. This morning I said try to solve this, and not very many people even came close to solving it, but because I think they lacked the technique. So if you have an x on the bottom, what I would do is multiply everything by that x. Okay, in other words, you want to strip off the x on the bottom of this fraction by multiplying it by an x up here, so it cancels. But you're going to have to distribute all three times here, and don't forget to multiply this side over here. Now, this side on the right, x times 0, will of course be 0. But on the left, okay, if you know it, blurt it. X times 12 over x would be what? Good, 12. Because the reason why is that's x over 1 times 12 over x, and that would cancel, leaving you 12 over 1, which is just 12. Now, what is x times x? That's x squared, and x times negative 8 would be minus 8x. Let me go back to a little bit brighter color. I'm going to rearrange this. You know that's quadratic right there. I mean, that is just screaming second degree polynomial. So if I reorder that, that's going to be x squared minus 8x plus 12 equals 0. Now, all the ways that we've talked about how to solve this at this point, you could use the quadratic formula. You could factor this. If you were skilled at factoring, you could get it done, boom, right there. You could graph this and find the zeros on the graph like we did last night. And I'm going to pause this, and that's what I want you to try. So I'll be right back. All right, now, we in class just did the zeros on that. And you could use a quadratic formula, but just to review, I'm going to do factoring, because factoring trinomials into two binomials is the fastest way to do it. If you are super slick at it, let's see, this is going to be minus 6 minus 2 equals 0, which the zeros, in other words, what you would put in for these x's here to make that equal 0 would be 6 and 2. And so those are my two zeros on that. But this would be another way of finding a 0. Okay, so that's one technique. And the technique there is, of course, multiplying by the denominator to unload that variable on the bottom. Let's look at a different one. This will be our final problem of this video. This, my friends, is called a proportion. Okay? One of the most useful things ever in math, a proportion. What a wonderful thing. Usually you see them in pre-algebra, and it looks something like this. 2/5 equals x over 10. And to solve that, you would cross-multiply like this and get 5x equals 20, and x would equal 4. That's a review of pre-algebra of proportions. This is the same thing, though. These are two fractions equal to one another. And if you're thinking, well, can I just cross-multiply? You would be correct. You can cross-multiply. So I'm going to cross-multiply. It's hard to draw a yellow arrowhead through that and not get all over it. But 3 times x plus 5. Now remember, you're doing this. You're doing that stuff right there. So that would be 3x plus 15. And on the other side, what would you get? 27. Good. And then you just solve for x. Try to beat me down. I dare you. Okay, I'm just going to go ahead and subtract 3x. 15 is 6x plus minus 27. And I would add 27. That's 42 equals 6x. Divide both sides by 6. X equals 7. 7. And if you're wondering, well, how would I check that? Well, you would just plug it in. Let's do that real fast just to show you. 7 plus 5, does that equal 3 over 7 minus 3? So I plugged in for these two x's the 7 here. So that'd be 9/12. This would be 3/4. Does 9/12 equal 3/4? Of course it does. This right here reduces by 3 to 3/4. So 3/4 would equal 3/4. That would be correct. All right. Have a good one.